Hi all, welcome back to Oops with C++ session 18. In previous session, we have seen how to pass the arguments by address to the function arguments. Another method left out in passing arguments to the function is call by reference. So before going to call by reference, first we have to see reference variables, how to declare or how to create a reference variables. After that, we will see how to pass the reference variables to function arguments for call by reference method. Okay, so before going to reference variables, what I felt is uh, pointers to versus constants, you need some idea. Then only you can understand a reference variables concept properly. So that's the reason I'm keeping this session before reference variables. So in today's session, we'll see pointers and constantness. Okay, okay. So now we have four different types of topics here. A pointer to a normal variable means a non-constant pointer to a non-constant variable, and a pointer to a constant pointer to a variable, constant pointer to a constant variable. So in today's session, we will see all these different types of pointers, and we will see what is the difference among these four. Okay. Okay. So first thing is pointer to a variable, or you can say a non-constant pointer to a non-constant variable. So what do you mean by constant? So constant means read only. Once the value is assigned, it cannot be changed. Okay. So now general syntax, assume you have a data type, a variable, and you have given some value, and data type star btr equals to address of so the variable. This is the general pointer syntax. Let's see what will happen in this type. We will take some example for this. Okay, example, I have one integer variable 1 equals to 10. So data type is integer variable, okay, and value is 10. Next, what I have doing is int star ptr equals to address of variable. Now this is a integer pointer holding address of this variable 1. And again, I have given some declaration for another variable int variable 2 equals to 1 2 3 4. Okay, now here int variable 1 equals to 10. When you say like this, then in memory some thousand address variable 10 variable 1 is getting memory here in 1000 memory location with the value 10. Okay, next ptr is also a pointer variable, so even it requires a memory of 4 bytes, and now this pointer is holding address of a variable 1, that is 1000. Okay, now this pointer is pointing to variable 1. So next we have variable 2 equals to 1 2 3 4. So variable 2 another memory location, maybe 1008 memory location, and the value 1 2 3 4 is given to this. So this variable 1 is present at 1000 memory location. So PTR is a special type of variable, that is a pointer variable which will holds the addresses only. Okay, now it is holding address of the variable 1, that is 1000, and it is pointing to variable 1. Okay, so this is variable 2. Okay, now just see these operations. So what I'm doing is star ptr equals to 20, means star ptr means the value present in the address of ptr has to be changed to 20, means in the ptr whose address is there, variable 1, that is 1000. So whatever, wherever it is pointing, in that place the value has to be changed from 10 to 20. So now previously here 10 is there. Now we have to modify to 20. The value is changed. It's we can access through pointer, this variable we can access by using star ptr, and we are directly modifying the value here. Okay. So next ptr equals to address of variable 2. Now what I'm doing? So previously this pointer is holding address of variable 1. Now what I'm trying to do is I am trying to change the pointer to point variable to address means it is holding the value of 1004, that is variable to no, sorry 1008, that is variable to address. Okay, so now the the pointer will point to variable 2. Okay, so both are valid operations. Now if you are doing star ptr equals to some 20 or 30, then it will modify it to this location, variable 2 location. So this is perfectly legal operations. Okay, now so this is with respect to a normal pointer. So if you want to modify any value by using a pointer, so then you can use star ptr. And if you are changing the address, if you are changing or if you are making your pointer to point some other variable, then you are using ptr equals to address of variable 2. Okay, now next type, so pointer to a constant variable. Now let's observe. So here what I'm saying, I am creating a pointer, but the it is pointing to a constant variable. So for that, so generally data type variable equals to value. Now this is a normal variable. Now what I'm doing, you have to create a pointer which is pointing to a constant data member, means wherever it is pointing, that particular value variable will behave like a constant. Okay, now constant data type star ptr equals to address of variable. Okay, now we'll see some example. Okay, so here int variable equals to 10. Now variable 1 equals to 10. Okay, so it is at memory location 1000. So next what I'm doing, constant int star ptr equals to address of variable 1. Okay, so it is just like a normal syntax. The only thing is just added constant keyword here. Okay, before int, or either it will be constant or int const. Both are same. Either you write const before int or you write const after int. No problem. Okay, so now const int star ptr equals to address of variable 1. So again, so ptr is a normal variable. Now, sorry, it is a ptr is a special type of variable which is holding only addresses of the variables. Now, ptr is pointing to variable 1 and who it is holding address of 1000. Okay. Now, if you see here, ptr is pointer to a constant, means wherever it is pointing, where it is pointing, ptr is pointing to memory location 1000. This particular location is a constantness, means for this read only property is applied. Okay, now int variable 2 equals to 1 2 3 4. So I have created int variable 2 equals to 1 2 3 4. That's fine. Now what I'm doing is I am trying to do star ptr equals to 20, means wherever it is pointing, that particular place I am changing the value, means the 1000 memory location wherever it is, there I am changing the value. But here ptr is pointing to a constant property, means wherever it is pointing, that particular memory will be treated as a constant. So you are trying to modify this value, so that is illegal operation. So your compiler will throw an error because you are trying to modify a constantness value of this star ptr equals to 20 is invalid, and ptr equals to address of variable 2. Now this is possible. Now you can, if you want, you can make it to point to some other variable. So other variables address it can hold, but wherever it is pointing, that particular memory location will be treated as constant. So this is constant, it is illegal operation. Okay, but this is illegal operation, but what you can do, you can make this pointer point to variable 2. That is possible. So this is valid syntax. Okay, you cannot modify it. I'm repeating once again. So when you have a pointer to a constant, wherever the pointer is pointing, that particular memory location value will be treated as a constant. So you cannot modify that. But you can make your pointer to point to some other variable. That is allowed. Like this, ptr equals to address of variable 2. This is allowed. This is not allowed. This is compile time error. Okay. Now, so now is constant pointer to a variable. Okay. So previous thing is, what is the previous thing? Pointer to a constant variable. Now we have constant pointer to a variable. Okay. So syntax, data type variable equals to value, data type star const ptr. Now if you see, const keyword is present after star. Previously it is before star, right? Now it is after star. Const ptr equals to address of variable. Now this pointer is a constant. Okay, so it is a constant pointer, and wherever it is pointing, that value is not a constant. Okay, now we will discuss with the example. Same, int variable 1 equals to 10, int star const ptr equals to address of variable 1, int variable 2 equals to int variable 1 equals to 10, int star const ptr equals to address of variable 1, int variable 2 equals to 1 2 3 4. Now variable 1 equals to 10, so at 1000 memory location. Now int star const ptr equals to address of variable 1, that is ptr is a pointer, constant pointer, which is holding address of variable 1, that is 1000 memory location. Now int variable 2 equals to 1 2 3 4, int variable 2 equals to 1 2 3 4. Now we'll see the operations. Star ptr equals to 20. Now what I'm saying, const ptr. So ptr is constant, means once the value present, whatever the value present here, it is a constant. Once you have given some value to this pointer, then it is constant. You are not, this will be constant. So previously in pointer to constant, the variable 1, that is wherever it is pointing, that value is constant, but you can make your pointer to change to some other variable. Okay, but here constant pointer to a variable means this pointer is there. This pointer, once you have assigned here some value, int star constant ptr equals to address of variable 1. Now the ptr is having the address 1000. Now if you are trying to change the value wherever it is pointing, say star ptr equals to 20. Now the ptr is pointing to variable 1. But wherever it is pointing, that particular memory location is not a constant. This is not a constant. So you can modify it. It is a legal operation. Okay. But the second one, ptr equals to address of variable 2. Now you are trying to make your pointer to point to variable 2. That is illegal operation. So that is not allowed. So star ptr equals to 20 means this is valid. So that's the reason the value is changed. Now ptr equals to address of variable 2. So this is invalid. Okay. I think you got the difference between pointer to a constant and constant pointer. In pointer to constant, wherever the pointer is pointing, that particular variable value will be treated as constant, and you cannot modify that one. Means star ptr equals to 20, that is invalid. But in constant pointer to a variable, the value present inside the pointer is constant. Means this value is constant. Okay. See, when you have a constant pointer, you cannot do this also. ptr equals to address of variable 2. And one more thing, assume that you have int star const ptr. Next you have given ptr equals to address of variable 1. That is also not allowed. So whenever you are using constant pointer, you have to give the value, you have to give the address in the same line only. Declaration and defining has to be in the same line when you are using a constant pointer. Okay. So you cannot say int variable 1 equals to 10, next int star constant ptr, next line ptr equals to address of variable 1. That is not allowed. You have to write it int star const ptr equals to address of variable 1. because it is a constant name. You have to, because once you give int star constant PTR, then some garbage value will be present in this. If you are not giving int star const PTR equals address of variable one, then that garbage value will be treated as constant. You cannot make your pointer to point to some other because of the constantness property. You have to follow this syntax only. Okay, declaration and definition has to be present in the same line. Okay, so when you have a constant pointer to a variable, non-constant variable, wherever it is pointing, that particular value you can change, but you cannot make your pointer to point to some other variable. Okay, that is illegal operation. Okay, next, the last one, constant pointer to a constant value. So now data type variable equals to value. We have constant property before the data type. We have constant property after the star also. Means pointer is also constant, and wherever it is pointing, that particular location value is also be constant. So now constant data type star const ptr. Okay, you can, now we'll take one example. Same example, int variable 1 equals to 10, const int star const ptr equals to address of variable 1, int variable 2 equals to 1 2 3 4. So variable 1 memory location 1000 memory location, and the value present here is 10. Sorry. Next, constant int star const ptr. Now the pointer ptr, we are creating one pointer ptr is a constant pointer to a constant integer. So it is a constant pointer to a constant integer. Okay, and which is holding address of variable 1. Right. Now ptr is a constant pointer which is holding address of variable 1, that is 1000 memory location it is having. Now wherever it is pointing, this place is also constant, and the value present in this ptr is also constant. So this value also you cannot modify, and this value also you cannot modify. Okay, by using pointer. Okay, by using pointer you cannot modify this value also, and you cannot modify the value present inside pointer also. And variable 2 at 1008 memory location, variable 2 equals to 1 2 3 4. Okay, so now what we are doing, star ptr equals to 20. Now I am trying to modify the value where it is pointing. So it is pointing, the ptr is pointing to variable 1, but since it is a constant, variable, I am not able to modify this. This we cannot modify. And also ptr equals to address of variable 2. So pointer is also constant. So the value present inside the pointer is also constant. So you cannot do both the operations. Both are illegal operations. Okay, both are not allowed. Okay, so here also the declaration and definition has to be present in the same line. You cannot split it into two different lines. Okay, this is how constant pointer to a constant variable will work. Okay, so we have non-constant pointer, non-constant pointer to a non-constant variable, and we have constant pointer to a non-constant variable, non-constant pointer to a constant variable, constant pointer to a constant variable. Okay, all these four, right? So now remember few points here. Okay, a non-constant pointer holding address of a non-constant variable, the first case, can change the value of the variable, means wherever it is pointing, that is star ptr equals to 20, that is allowed, as well as it will be able to point to another variable also, means ptr equals to address of variable 2, that is both are valid. Star ptr equals to 20, ptr equals to address of variable 2, both are valid in the first scenario. In the second scenario, a non-constant pointer holding address of a constant variable. During that time, cannot be able to change the value of the variable, but it will be able to point to another variable because it is pointing to a constant variable. Now in this case what will happen? Star ptr equals to 20, that is invalid, but ptr equals to address of variable 2, that is valid. Third scenario, a constant pointer holding address of a non-constant variable. So third scenario, pointer is a constant, but wherever it is pointing, that is not a constant. In that case, can change the value of the variable, that is star ptr equals to 20, that is valid, but it will not be able to point to another variable. Means ptr equals to address of variable 2, that is not allowed, that is illegal operation. Fourth scenario, a constant pointer holding address of a constant variable. In this case, we will not be able to change the value of the variable, as well as it is not be able to point to another variable also. So means star ptr equals to 20 and ptr equals to address of variable 2, both are invalid operations. Okay, both are illegal operation, both we should not use. Okay, now you have to one more thing here. If a variable is declared as constant, then you can hold the address of that variable with constant pointer only. Say for example, assume you have declared this variable like this, const int a equals to 10. During that time, what you have to do? You have to use this syntax only to hold the address of this variable. Const int star ptr equals to address of a and address of a. Okay, but it is not allowed. Int star ptr1 equals to address of a, that is not allowed. This is illegal operation. Okay, when you are having a constant variable like this, you have to use this syntax only. Why it is not allowed? Say if it is a normal pointer, right? It is a non-constant pointer to a non-constant value. Now by using this syntax, what I can do? Star ptr1 equals to some value I can assign, but actually this is a constant variable. So constant means once the value is given to this, you are not supposed to change. Means the value is fixed. It is constant. It cannot be modified. Okay. But if you are allowing this type of syntax, int star ptr1 equals address of a, then by using this pointer, you have a chance of modifying this value. So when the variable is a constant, this particular syntax is not allowed. It will throw compiler error only. So you have to follow this syntax, const int star ptr equals to address of a. Okay. So remember all these points. Please go through this before the next session, that is reference variables. Okay. So if you have understood these things, then understanding reference variables, call by reference will be easy. Okay. Thank you. Thanks for watching.